Next up, it is my honor to introduce Professor Allan Dafoe. He is an assistant professor of political science at Yale University and a research associate at the Future of Humanity Institute at Oxford, where he is involved in building the AI Politics and Policy Group. His research seeks to understand the causes of world peace and stability. Specifically, he has examined the causes of the liberal peace and the role of reputation and honor as motives for war. Along the way, he has developed methodological tools and approaches to enable more transparent, credible causal inference. More recently, he has focused on artificial intelligence grand strategy, which he believes poses existential challenges and also opportunities, and which requires us to clearly perceive the emerging strategic landscape in order to help humanity navigate safely through it. To discuss his work on AI and international politics, please welcome Professor Allan Dafoe.
Thank you, Nathan.
Thank you.
Thank you, Nathan. So I will actually start by talking about war, and then we'll get to AI, because I think there's some lessons for effective altruism. So war is generally understood to be a bad thing. It kills people, it maims them, destroys communities, ecosystems, and is often harmful to economies. We want to add an asterisk to that, because in the long run, war has had dynamic benefits. But in the current world, war is likely a net negative that we would want to avoid. So if we were going to start a research group studying the causes of war for the purposes of reducing it, we might ask ourselves, well, what kinds of wars should we study? There are many kinds of wars that have different causes, and some are worse than others. So one classification that we might employ is to bin wars in terms of how many people they kill. There's some wars that kill only 1,000 to 10,000, some that kill 100,000 to 1 million. And so the x-axis here are the bins of the fatality, the battle deaths in wars. And the y-axis is the fraction of wars of those kinds. So an instinct we might have is to say, well, let's study the wars that are most common, right? Those on the first bin. These are the wars that are happening today in Syria, civil wars. Availability bias would suggest that those are the wars we should worry about. Some of my colleagues have argued that great power war, the big wars, world wars, are a thing of the past. Right? The liberal peace, democracy, capitalism, nuclear weapons have all rendered great power war obsolete. We're not going to have them again. The probability is too low. But as effective altruists, we know that you can't just kind of round a small number down to 0, or you don't want to do that. You want to really try to think carefully about the expected value of different kinds of actions. And so it's important that even though those probabilities of a war of, say, a million, 10 million, 100 million, or 1 billion is very small, it's not 0. If we look at the past 70 years of history, World War II stands out as the source of most of the battle deaths that have been experienced. So that would suggest if fatalities is a good enough proxy for whatever metric of importance you have, that we first really want to make sure we understand World War II and the kinds of wars that are like it, that are likely to kill so many people. We can zoom out more, and World War I comes out of the sort of froth of civil wars. And really, those two wars loom above everything else as the thing we want to first explain, at least if we're prioritizing importance. We can see this in this graph, which, again, has these bins of size of violent quarrels. Now we're going all the way down to homicides. And we see that the world wars, the 10 million bin on the right, contains, again, most of the deaths in violent quarrels. So that, again, would suggest that it's really important that we understand these big wars. But of course, the next war need not limit itself to 99 million deaths. There could be a war that kills hundreds of millions, or even billions, or even 6.5 billion. Now, the problem, empirically, is that we don't have those wars in the data set, so we don't know how to estimate non-parametrically the expected value in those. We can try to extrapolate from what's very close to a power law distribution, and pretty much no matter how we do it, unless we're extremely, extremely conservative, we get a distribution that looks like this, which says that most of the harm from war comes from the wars that kill 1 billion people or more. Of course, we haven't had those wars, but nevertheless, this follows from the reasoning. But even still, we go further. The loss from a war that kills 6.5 billion is not just those 6.5 billion people that die, the currently existing people. It's also all future people, right? And this is where the idea of existential risk and sort of existential value comes in. We have to ask ourselves, what is the value of the future, right? How much worth do we give to future human lives? There's many ways you can answer that question, and then you want to discount in various ways for model uncertainty and different things. But one thing that drives concern with existential risk, which I'm concerned with and the Future of Humanity Institute is concerned with, is that there's so much potential in the future. There are so many potential lives that could be lived that anything that cuts that off has tremendous disvalue. And so one estimate would put it at, and this is quite a conservative estimate, if there's only 1 billion people living on Earth, and they continue living in a sustainable way for 1 billion years, which is doable as long as we don't muck it up, that gives you 10,000 trillion lives, which is a lot. And so anything that reduces the probability of extinction, of losing those 10,000 trillion lives, by even a little bit, has a lot of expected value. OK, now that's a very small number, 1/10 trillionth, and it's hard to know if you're making that big of, or if you're making less of an effect than that. It looks close to 0. The numbers aren't meant to be taken too seriously. They're more thinking heuristics, right? They illustrate that if you give value to the future, you really want to worry about anything that poses a risk of extinction. And one thing that I and others, and one group I'll note is Open Philanthropy Project, have identified as a risk to the future is artificial intelligence. Before telling you about the risk, I'm going to first tell you about what's up with AI these days. So for a long time, artificial intelligence consisted of what we would now call good old-fashioned AI. There was a programmer who wrote if-then statements, trying to encode some idea of what was a good behavior that was meant to be automated. So for example, chess algorithms, you would have a chess master say, here are the heuristics I use, here's the value function. You put it in a machine, the machine runs it reliably and more quickly than a human can do, and that's sort of an effective algorithm. But it turns out good old-fashioned AI just couldn't hack a number of problems, even simple ones that we do in an instant, like recognizing faces, images, and other things. More recently, what's sort of taken over is what's called machine learning. This is what it sounds like, machines learning for themselves solutions to problems. And other terms for this are deep learning. That's especially flexible machine learning. You can think of it as just a flexible optimization procedure. It's an algorithm that's just trying to find a solution and has a lot of parameters. And neural networks is another term you've probably heard. OK, so this is showing basically the breakthrough recently in image classification arising from neural networks and the year-on-year improvements to the point where now machines are better than humans at image classification. Another domain is generalized game playing or arcade game playing. Here are Atari games. Probably not many of us have played these. DeepMind has built a machine. DeepMind's a leading AI group within Google that learned to play Atari games at a superhuman level with no instructions about anything. No instructions about the nature of the universe, what is time and space, what is a bad guy, and here's Pac-Man, what is a pellet, and what is a ghost. All the machine is told or is given is pixel input. It just sees the screen from a blank slate sort of beginning, and then it plays the game again and again and again, getting its score, and it tries to optimize for the score. And gradually, over the span of about a day, it learns to make sense of this pixel input, to derive concepts of sort of the bad guy, the ghost, the pellets, devise strategies, and become superhuman at a range of games. Another domain we see this is Go. And the solution to Go was very similar. You take a blank slate neural network that's sufficiently flexible, have it first be exposed to lots of human games, and learn to predict the human move. Then you have the machine play itself again and again on the order of about 10 million games, and it becomes superhuman. So here's Lee Sedol and AlphaGo, which is another product of DeepMind. And Lee Sedol was the first real excellent Go player who publicly played AlphaGo. And here he's saying in February 2016, just last year, I think I will win the game by a near landslide, at least this time. Well, as I've alluded to, that didn't work out. So here's him after the first game. I was very surprised because I didn't think I would lose. And unfortunately, he lost again. I'm quite speechless. I'm in shock. I can admit that. The third game is not going to be easy for me. He lost the third game. He did win the fourth game, and he talks about how it was sort of the greatest moment of his life. And it's probably the last game, the one and only game played against a level of AlphaGo of that level or better that a human will ever win. Now, I'm bringing out Lee Sedol and his losses for a reason, and that I think it serves as an allegory for humanity, that we don't want to be caught off guard when it's our AlphaGo moment. Right? At some point, machine intelligence will be better than us at strategically relevant tasks, and it would be prudent for us to see that coming, to have at least a few years' notice, if not more, to think through what it means, how we can adapt our international system, our politics, our notion of meaning in life, and other areas. OK, so what's driving this progress? Well, algorithms, talent, data, but a big thing driving it is hardware. Computing inputs just keep getting better at an exponential rate. This is sort of a generalized Moore's law across a range of inputs. And it's this kind of persistent progress that makes Kurzweil's graph from 2001 not seem totally absurd. So here we have, on the first y-axis, calculations per second per $1,000. And I added 4 recent dots from the past 17 years. And you see, basically, we're on track. We have exponential improvements. What we don't know is when we get to transformative AI. Right? Now, Kurzweil has this evocative second y-axis where you have organisms we recognize, mice, humans, and all humans. It's not obvious what the mapping should be between calculations per second and transformative AI. Intelligence is not a single dimension, so we could get superhuman AI in some domains long before other domains. But what I think is right about this graph is that at some point between 2020 or 2025 and 2080, big things are going to happen from machine intelligence. Now, in our work, we want to be a bit more systematic about these timelines. And there's various ways to do it. One way is to survey AI researchers. This is the result of a recent survey. And some takeaways are, one, there's huge disagreement about when human-level machine intelligence, defined here as machines better than all humans at every task, will come. So, as you can see by the sort of gray S-curves. Lots of disagreement. Two, the group that we surveyed gives enough probability mass that by 100 years, there still won't be human-level machine intelligence. But three, in the next 10 years or 20 years, this group gives a 10% to 20% chance that we will have reached it already. And if that probability seems right upon consideration, which I think it does, not just using this as evidence, I think that's more than sufficient warrant for us to invest a lot of resources thinking very hard about what that would mean for humanity. So here are some tasks. I like to think about milestones and canaries. What are some things that machines will eventually achieve that are either noteworthy or strategically relevant? And the canaries are those that, when they die, when they go off, signal to us that we better be paying attention because things are going to change quickly. I expect most of these tasks on the right column will soon be moving over to the left column if they're not there already. So this is something else we're working on. More generally, there's a whole host of challenges, near, medium term, and long term, that we will be working on, we as a society, but also at FHI. There's a range of near-term issues that I'm not going to talk about. Each of those could occupy a workshop or a conference. I will say that when thinking about long-term issues, we also confront the near-term issues. For one reason, because the near-term issues, or the long-term issues, often look like the near-term issues magnified 100-fold. But two, because a lot of the long-term insights that we have and strategies and policy interventions we want to make have a most appropriate place of action in the near term. OK, but what are the long-term opportunities and risks? Well, the opportunities are tremendous. We often just think it's sort of greater wealth, and maybe Google stock will go up, but it's a lot more. Longevity, health, preventative medicine, material bounty that could be used to end poverty, though it need not, because it will also likely come in a more unequal world. Reduced environmental impact. DeepMind was able to reduce energy usage at Google data centers by 40%. But also, basically anything else that we value is either the product of intelligence or depends on intelligence for its protection. And so if we have superhuman intelligence, then in principle, we can use that to achieve all our goals. I'll also emphasize the last point, resilience to other existential risks. We're likely to face those in the coming 100 years. And if we solve AI, if we build it well, then that could reduce those other risks by a large margin. But of course, there's also risks with bringing into the ecosystem a creature that is better than us at the thing that matters most for our survival and flourishing. I'm not going to go through this typology. I will illuminate the risk by quoting Max Tegmark and others. One can imagine such technology outsmarting financial markets, out-inventing human researchers, out-manipulating human leaders, and developing weapons we cannot even understand. Whereas the short-term impact of AI depends on who controls it, the long-term impact depends on whether it can be controlled at all. I will also appeal to another authority. This is from my world. I'm a scholar of international relations. Henry Kissinger, as you know, is also very worried about AI. And this is sort of the definition of a grand strategist. Modern technology poses challenges to world order and world stability that are absolutely unprecedented. I personally believe that artificial intelligence is a crucial one, lest we wind up creating instruments in relation to which we are like the Incas to the Spanish. That our own creations have a better capacity to calculate than we do. It's a problem we need to understand on a global basis. OK, in addition to these quotes, the AI researchers we surveyed also agree. We asked them what the long-term prospects are for human-level machine intelligence. And while most of the probability mass was on extremely good or on balance good, the median respondent gave a 5% probability to it being extremely bad or human extinction. That is human extinction. It's not often you get an industry that says that their activities give rise to a 5% chance of human extinction. I think it should be our goal to take that number, whatever the real sort of frequentist number is, and push as close to 0 as we can get, and push as much of that probability mass up to the top. There's two broad ways we can do that. One is to work on what's called AI safety. The computer scientists in the room and mathematicians can help build AI systems that are unlikely to misbehave without our intentions. OK, and the other way is AI strategy, which I'm going to talk about. So here's Stuart Russell explaining that we're not worried about machines suddenly waking up and deciding they want to build their own machine utopia and get rid of humans. It's not some kind of emergent consciousness. The worry is that they will be hyper-optimizers, which is what we're building them to do, and that we will have not specified their value function correctly. And so they will optimize for the wrong thing. This is broadly called the control problem or the value alignment problem. Here are some groups working on this or funding it. I'm going to keep moving. Here are some people who you can't really make out, but I will tell you that they are leading researchers and industrialists from the most prominent AI groups in the world. And they came together this January at Asilomar to really think seriously about AI safety, which I think is a tremendous achievement for the community that we've brought everyone together like this. And I'm showing this as a reflection of how exciting a time it is for you to be involved in this. OK, so one conjecture that's been posed is that AI value alignment is actually not that hard of a problem, as long as we have enough time, once we have the final system we want to deploy, to test it. Right? It's like drug tests. You have the thing you are thinking about deploying in the population. Let's just make sure it undergoes sufficient scrutiny. However, this conjecture goes, it is almost impossible, AI value alignment, if we don't have that time. Well, if that's right, which seems plausible, then it directs attention to the world in which this system is being deployed. Is it one where the developers have the incentives and the time to do these safety tests? And this is one of the big things AI strategy thinks about. Basically, how we can prevent a race in AI. Here's the CEO of DeepMind basically saying this point. We want to avoid a harmful race to the finish where corner cutting starts happening and safety gets cut. This is a big issue on a global scale, and it's extra hard when you're talking about national governments. Right? It's not just a race between companies in the US, it's a race between countries. So what do we think about in AI strategy? A lot. So one thing we think a lot about is what AI races and AI arms races would look like. Another whole class of issues is what AI could look like militarily. What are some implications of AI for the military in terms of balance of power, crisis stability, uncertainty about capabilities. Another thing we think about is what it means economically if we live in a world, say, where AI is really the engine of growth and value in societies, which increasingly seems to be the case. So the top 10 firms by market capitalization, either 5 or 6 are AI companies. Google, Amazon, Apple, Microsoft. And so in such a world, what do countries do like Saudi Arabia or France that don't have their own Google or Amazon? But they want to be part of that value chain. And so we may be entering an era of AI nationalism, where countries want to build their own national champion. And China is certainly in the business of doing this. And lastly, there's a lot of issues. These are very high-level categories. Is this massive challenge of AI governance, both at the near-term small scale, how do we govern algorithms that are being used for judicial sentencing or self-driving cars, to the long-run scale of what kind of electoral system, what voting rules do we want to use for the organization that's going to be deciding on how to test the superintelligence and how to deploy it. These are very hard questions. And I want to make clear that these are questions that are being asked today by the leading AI groups. So here's Sam Altman, Demis Hassabis, asking these questions. Like, literally, what is the voting rule that we should use for control of our superintelligence once we build it? Well, they didn't literally say that, but that's the site for governance today is the Partnership on AI. This is a private sector organization that has recently brought in NGOs, including the Future of Humanity Institute. And it's plausible that this will do a good job guiding AI in the near term and could grow in the longer term. At some point, governments are likely to get more involved, and so that's a site for study and for intervention. Another thing we can do is to try to articulate principles of good governance of AI. And these are some principles that came out of the Asilomar conference. Again, hat tip to Max Tegmark for putting that together, and especially these principles. So we might want to work to identify important principles that we can get different communities to agree on, and then formalize them, institutionalize them to make sure they stick. So in summary, what's to be done? A lot of work. What kind of skills do we need? Virtually every skill set. Everything from people who can help us grow the community, operations, people, administrative experts, and people who are enthusiastic and efficient. We need people who do policy engagement, outreach, can form media strategy. What should be, say, the media strategy of a group like the Future of Humanity Institute or others when there's another self-driving car incident, or when, say, truckers are being massively displaced from their sites of employment. These are important near-term issues, but also they're sites for having conversations about the longer-term issue. We're doing work on strategy, theoretical work, mathematical modeling of tech races, trying to understand AI development, what predicts innovation, measuring actual capabilities in different sites in the world, countries, understand the value chain and supply chain of AI. We're surveying publics throughout the world and elites. We're trying to design safety standards, working with AI safety researchers, and a range of other issues. So if this seems important to you and it's interesting, I strongly encourage you to get involved. There's a link there, AI Policy Career Guide, that has some text that can sort of point you in the right direction. There's also a reading list there. And in general, just please reach out to me. Carrick Flynn is here from the Future of Humanity Institute as well, and he's helping us build up that site. And there's people working on this in a range, or beginning to work on this at a range of sites. So we'd be very happy to help you be productively engaged. Thanks.
Let's have a seat. You here, me here. I'm just going to remove this one.
OK.
So to submit your questions, you can go to boston.eaglobal.org/polls. I was encouraged to make sure we run all the questions through the website, just because the mics won't pick up people in the auditorium. So thank you for the talk and for being here. We'll give a second for questions to kind of come in. But one thing that I'm struck by is it seems like we're making a lot of progress. I mean, I've been involved in this community sort of on the edges for a number of years. And there was a time when to even talk about something like this, and that time was not long ago. I mean, 7, 8, 9, certainly 10 years ago, it was extremely, kind of fringe, and only weirdos sort of, seemed to be willing to go there. Now we've got respectable people like yourself and the growing body of academics that are getting involved. So it seems like there's been a ton of social progress. What is that translating to in terms of technical progress or sort of practical progress to try to get a handle on these issues? It seems like we're bringing people together, but what are those people producing so far? And should we feel any safer than we did 10 years ago?
Yeah, so I can speak most to the strategy side of it. I will remark that one sort of comment that was made at Asilomar that resonated as true to many people is that AI strategy is today what AI safety was 2 years ago. So the first beneficial AI sort of meeting at Puerto Rico, AI safety was really nascent. There was just a handful of individuals in the world thinking seriously and full time about it, and that's changed today. Now the leading AI groups have safety teams. There are people doing PhDs with an eye towards AI safety. So that's very exciting, and there has been a lot of sort of technical progress that's coming out of that. AI strategy is just where AI safety was 2 years ago, but I think it's rapidly scaling up. We haven't had enough time to, a lot of thinking has been done. It's not public yet, but I think in the coming year you will start to see a lot of really insightful sort of strategic analyses of AI existential risk. Yeah, and so I'll also say I've given some talks like this to other respectable audiences, political science workshops, and none of the PhD students think this is crazy. They all think, some of them think, oh, I don't have to quit smoking because of this, which was one comment. But they all think this is real, and the challenge for them is that the discipline doesn't entirely support work on the future. One question I got when I presented at Yale was, so how will you be empirical about this? Because we're social scientists, we like data, and we like to be empirical. And I remarked that, well, it is about the future, and it's hard to get data on that, but we try. And so, as some of the projects I listed. Anyhow, so I think it's a challenge for currently existing disciplines to adapt themselves to this problem, but increasingly we're finding good people who recognize the importance of the problem enough to take the time to work on it.
So first question, which I think is a good one coming in from the audience, could you give a little bit more detail on what an AI governance board might look like? Are you thinking more kind of blue ribbon panel of experts, or more of a free-for-all, everybody can contribute, open democracy type of structure?
Yeah, so I think there's a lot of possibilities, and I don't have a prescription at this point, so I'm not going to answer your question. But these are the issues we need to think through. So there's trade-offs. I can talk about the trade-offs. There's trade-offs between legitimacy on the one hand, right? The UN General Assembly, for example, is often seen as a legitimate organization because every country gets a vote. But it's not necessarily the most effective international body. So, and also you have to weight your institutions in terms of power holders. So if you have the most ideal governance proposal, it might be rejected by the people who actually have the power to enact it. So you need to work with those who have power, make sure that they sign on to the regime, and try to, I think, build in at early sites of intervention sort of the key properties of whatever this development regime is and governance regime, so that good comes out of it. And so I'll mention a few suggestions. Whatever development regime it is, I think it should have a constitution, some explicit text that says what it's about. What is it trying to achieve? 2, it should have enough transparency so that the relevant stakeholders, be that the citizens of the country, if not citizens of the world, can see that the regime is in fact building AI according to the Constitution. And I should say the Constitution should be a sort of common good principle type thing. And then 3, you want the regime to have accountability so that if it's not working out, there's a mechanism, a peaceful mechanism for changing the leadership. And these are basic principles of sort of institutional design, but it's important to get those built in.
So speaking of people in power, President Obama apparently was asked, and I haven't seen this clip, but was asked about risks related to artificial intelligence. And the answer that he gave seemed to sort of equate AI risk with kind of cybersecurity risk that we know and love today. Do you think that there is a sufficient understanding at the highest levels of power to even begin to make sense of this problem? Or do we have kind of a fundamental problem of lack of understanding that may be quite hard to overcome?
Yeah, so that's a great clip. I wish I could just throw it up really quickly. We don't have the AI yet to just do that. I encourage you to watch it. It's hard to find it the way Wired put it on their page. But so he's asked about superintelligence, and if he's worried about it, and he pauses, he hesitates, he gives sort of a considered hum or sigh, and then he says, "Well, I've talked to my advisors, and it doesn't seem to be a pressing concern." But the sort of pause and hesitation is enough to suggest that he really did think. I mean, Obama is a science fiction fan. He really did think about it seriously, and yeah. So I think he probably would have been in a good place to appreciate the risks as they arise. But I think, yeah, lots of people in the government are likely to dismiss. So lots of reports from military or government have put superintelligence worries as at least sufficiently distant that we don't really need to think or address it now. I will say, though, cybersecurity is likely to be a site where AI is transformative, at least in my assessment. So that's one domain to watch in particular.
Another question from the audience. If there is a 5% chance, or the same analysis would really hold even if it were a lower percentage chance of extinction due to AI, one would not be unreasonable to jump to the conclusion that, hey, maybe we should just not do this at all, right? It's just too hot to touch. Is there any, first of all, what do you think of that idea? And second, is there any prospect of making that decision globally and somehow sticking to it?
Yeah. So I'll flick back to the slide on opportunities. So I actually had a conversation the other day with family members and friends of the family. And one person at the table asked that question. Why don't, if it's so risky, why don't we not do it? And then another sort of friend of the family asked, what are the impacts of AI for medicine and for health and for curing diseases? And I think in many ways that, those are sort of two sides of the policy decision, that there are really tremendous opportunities from AI, not just the material things like increased material bounty, but really curing diseases, curing Alzheimer's, pretty much anything you can imagine that's the product of intelligence, could come from machine intelligence. So there's a real trade-off to be made. But then the other issue is stopping AI progress is politically infeasible. So I don't think it's a viable strategy, even if you thought that the trade-off weighed in favor of doing so. And I could talk a lot more about that, but yeah, that would be my position.
Probably last question that we can take, just due to time constraints, but thinking about kind of the ethical direction that we want to take as we go forward into the future, right? The value alignment problem. You had posed that notion that if we have 2 years, we can probably figure it out.
Yep.
But if we don't, maybe more than likely we can't. That strikes someone in the audience, and I would say kind of me too, as maybe even a little too optimistic, because we've been working for thousands of years on what it means to have a good life and what good is, right? So
right.
Do you think that we are closer to that than maybe I think we are, or how do you think about the kind of fundamental question of what is good in the first place?
Yeah, right. So to be clear, this conjecture, it's about whether a single person who knows what they want can build a super intelligent machine to advance those interests. It says nothing about whether, even if we all knew what we want, whether we could agree on what we want to build, let alone do we even know what we want. So the can we agree is the political governance question of, even if we all have sort of fundamental preferences, how do we aggregate those in a good way? And then there's the deeper question of what should we want? And yeah, those are hard questions that we need people working on, as I mentioned in the last slide. So moral philosophy and politics, what do we want? So we need your help figuring that out.
Well, thank you for wrestling with these issues and for doing your best to protect our future. Professor Allan Dafoe, thank you very much.